Okay, so we're going to pick up where we left off on 12.3. And just as a little review, we actually did this on the first day. So where are the functions of sine, cosine, and tangent positive? Okay, so if you remember, we had a little acronym, all students take calculus, and we'll review again why that's true. Putting in here the quadrant numbers, going counterclockwise, it's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And it's important, in order to understand where they're positive and negative, that you understand that sine x, or sine theta, we'll say, sine theta is y over r, cosine theta is x over r, and tangent theta is y over x. So in this quadrant, we see x is positive, y is positive. So and r is always positive. So r is always positive. So that would make these ratios, y over r, x over r, y over x, always positive. So we can see that all trig functions are positive in the first quadrant. Similarly, in the second quadrant, we can see that only x would be negative for any point in here, y is positive. That would make only the sine positive. So sine is positive here. Okay, in the third quadrant, both x and y are negative. So that would mean that this is going to be negative, sine will be negative, cosine will be negative, but tangent, on the other hand, will be a negative divided by a negative, and that's, of course, positive. So our tangent is positive here. And in the fourth quadrant, x is positive, but y would be negative, so only the cosine is positive here. And if we look at these first letters, we have ASTC, or all students take calculus. So you could remember which one of the trig functions are positive in any of those quadrants. Now, if sine is positive, cosecant is going to be positive too, because their reciprocals will always be positive. Tangent's positive, then cotangent's going to be positive also. If cosine's positive, then secant will be positive, because when we take the reciprocals, we don't change the sign. Got it? Okay, so going on. So how do we write each of these following as a function of an acute angle? Okay, the tangent of 334 degrees. The first thing that I want to do is see what quadrant is that in. So rotating, starting at on the positive x-axis and rotating all the way around, we have 90, 180, 270, all the way to 334 degrees. So from here all the way to here is 334 degrees, right? Okay, so now I need to find the reference angle. So what is the reference angle for 334 degrees? Anybody? You can still answer me. What's the reference angle? What is it, Danuta? 26 degrees. Okay, so 26 is right here, because all the way around is going to be 360, right? So that's 26 degrees. Well, that means this is equal to the tangent of 26 degrees, but is tangent positive or negative in that fourth quadrant? All students take calculus. Is it negative? So this is negative the tangent of 26 degrees. To answer this question, what you want to do in writing each of the following as a function of an acute angle, it is the quadrant that the terminal side is in determines if the trig function is positive or negative. And of course, we know that because what we just did. Okay, all students take calculus. This right here is always the reference angle. So to answer the question, write each of the following as a function of an acute angle. It's plus or minus, depending on which quadrant it's in, the same trig ratio, and then the reference angle. Okay, let's do one more. Okay, secant of negative 106. So remember, negative is a thank you, Tate, a clockwise rotation. So x, y. So I have negative 90, negative 106. And we see, of course, that now we know that that is a third quadrant angle. What's the reference angle here? 74 degrees is my reference angle. Okay, so this is going to be, now, is secant positive or negative in the third quadrant? It's think when it's secant, think cosine, right? Cosine, only tangent's positive. Cosine is negative. So we have negative secant, and then the reference angle, 74 degrees. Okay? Everybody have time to write this? Okay. Cosecant, you do this. What should I do? Okay, do it at your seats. I'm going to give you a minute. You too. So that's my angle, not to scale, 180 degrees minus 117.8 to find my reference. So my reference angle is 62.2 degrees. Did you all agree? Right? So what is the final answer? Anybody? Maddie, do you know? If the reference angle is 62, what is this? How would I write this as a function of an acute angle? Which is cosecant. Go ahead. Cosecant of what? Right. And is it positive or negative, Maddie? Okay, how do you know? Okay, and what is in the what's positive in the second quadrant? So if sine is positive, then cosecant is going to be positive too, because it's reciprocal. So this is actually a positive. Oh, because the way we figure the trig functions is by the triangle that's formed by using the reference angle. Yet when we do those triangles, and we'll do them in a few minutes, okay, we're going to have negative sides, not just positive sides also. Okay, so find the values of trig functions in a quadrantal angle. Whenever you see quadrantal angles, I don't want you to think triangles. I want you to think of the unit circle. Okay, so I'm going to just draw a unit circle here, and we'll see why. Okay, so a unit circle means the radius is 1. So if the radius is 1, this point here, if this is the center is 0, 0, this point here would be 1, 0. This point up here would be 0, negative 1. This point here would be negative 1, 0. And down here, we'll have 0, negative 1. Yes, Charlie, go ahead. Oh, thank you. Charlie corrected me, and he's right. It's 0, positive 1. Okay? There. So what do I want you to remember? Quadrantal angles. Do not think triangles. Think the circle. And here's why. Because there's no triangle to draw. If I want the cosine of 90, then I am going to start. I'm going to just take a light color pen here for a second. Let's do something light. Okay. So I'm going to start at 0 degrees, and I'm going to go up to 90 degrees. And where am I going to end up? Where am I ending up? On the y-axis here. There's no triangle to draw, is there? Okay, but I do know this relationship. I know that cosine is x over r. Right? Now in a unit circle, okay, r is 1, because that's how I drew it. Okay? And each one of these is x, y. So what's the cosine of 90? What point on the circle does this angle hit? A 90-degree angle. What point on the circle? This point up here? 0, 1. So what's x? 0, and r is 1. So that's 0. So quadrantal angles, think circles. Think your unit circle. Similarly, sine of 270. The sine is y over r. Right? So I start at 0. I'm going to go light again. Start at, my rotation goes from 0 to 90 to 180 to 270. So that's so light. Can you see that still? It's pretty light. Can you see it? Yes? No? Yes? Okay, so that's at 270 degrees. What point on the circle does that hit? 0, negative 1. So what is the sine of 270? What's y? And r is always 1, right? So that's negative 1. Okay, how about the cosecant? The cosecant is what? The cosecant is the reciprocal of the sine. So instead of being y over r, it's r over y. And at 0 degrees, I haven't moved any place. What's r? R is always 1, but what's y? 0. So what is that? Undefined or indeterminate. We good? Go on to the next page. Okay, we don't need that. Okay, find the exact value of the 6 trig functions of the angle. And this goes back to, we're going to use a few things here. We're going to use our idea of a reference angle, and all students take calculus and answer, I think, a question we had before. So the first thing that you do is you draw your terminal side. Okay, so um, you're going to start wherever. Start when you're, I was picking whatever color, not like you start wherever. So you start at the x-axis, and you're going to go 90, 180, 240. And now draw your terminal side. Okay, from any point on the terminal side, any point on the terminal side, you can draw a line straight up to the x-axis. Now this right here is your reference angle, what the terminal side makes with the x-axis. How much was that? How much is that reference angle? If this was 240, it's this acute angle right here. This is the acute angle right here. So how much is it? Ariel, do you see that 60? So that's 60 degrees. Now if this is 90 degrees, what does this angle have to be? 30. And that's one of our special triangles, right? So, okay, we knew it was 60 because we took 240 minus 180, and that was 60, okay? So now we have this special triangle. It's not to scale. This is not to scale. Okay, and the shortest side, which is not to scale, okay, we can call 1. The side opposite the 60-degree angle, we can say is the square root of 3. And the hypotenuse, which is the same as r, is 2. Okay, hey, now you've got a triangle. You can use the relationships of y over r, x over r, y over x for the trig functions, or you could use SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, right? So let's write out what are our 6 trig functions. We have sine of theta, cosine of theta, tangent of theta. Oops, I forgot to do something. Okay, so what's important here, really important, is do you see how we went negative here? We're going in the negative direction. This is negative 1. We went down. This is negative the square root of 3. Really important. Any questions on that before I go on? Yes, Sierra. Huh? No. Great question. The hypotenuse is always positive, or the radius is always positive. So let's see, using your plus and minuses, you're using your positive and negatives. Zach, what is the sign of the of this? Sign is use SOHCAHTOA. So is what? Opposite over hypotenuse. Okay? So, what is it? This is your reference angle, right here. What's the opposite side? The angle is always looking at its opposite side. So it's right here, negative the square root of 3. Do you see that? Okay, and wrote theta here. I don't need to write theta. I actually know it's 240 degrees. So Zach, tell me again, what's the sign? So its opposite is negative the square root of 3 over the hypotenuse, which is 2, right? So it's negative the square root of 3 over 2. How about the cosine? Ariel, what's the cosine of 240 degrees? Yes. And Teddy, what is the tangent? Tangent is opposite over adjacent. What's opposite? Negative root 3 over negative 1, right? Thank you. And that, of course, is just positive root 3. So remember I said we were going to use SOHCAHTOA? Let's confirm that we actually are correct. What is the only trig function that is positive in the third quadrant? Tangent. And that is, in fact, the only one we see. But when I say the only one of the basic three, because we also have cosecant of 240 degrees, which is the reciprocal of the sine. So it's negative 2 over the square root of 3, but we don't want the radicals in the denominator, so we have negative 2 rad 3 over 3. The secant, which is the reciprocal of the cosine, so it's negative 2, and the cotangent, which is the reciprocal of the tangent, which is going to turn out to be negative radical 3 over 3. Because it's 1 over radical 3, which is positive radical 3 over 3. Any questions on this? Because I'll stop here and take any questions. So what's a few takeaways from here? What do? Recapping again, draw your terminal side. If you need to write this down, what we've done, draw your terminal side. Find your reference angle. Fill in the values for the special triangle. Remember to put plus or minus depending on which direction you're going in. And then list your trig functions, and using SOHCAHTOA, or x or sine is x over sine is y over r, cosine is x over r, tangent is y over x. Using either that or SOHCAHTOA, find the values of the trig functions. Question there? Okay. So you really need to know those special triangles. And you should have them in your notes already, right? Now you can memorize the values too, because it's like eventually, eventually you will just need to know that the sine of 60 degrees is square root of 3 over 2, cosine is 1/2, tangent is radical 3. You'll need to know it like you know your multiplication tables. But, excuse me, this is correct. But for right now, you can just know your special triangles. So I'm going to stop for a second. I can't tell if that's turned. Oops. Stop. Oh, stop coughing. So one of the students just asked about values for other angles. Notice this problem said, find the exact value. Now, I don't know the exact value for the cosine of 20 degrees, but I do know them for 30, 60, 90, 45 degrees. Okay, 180, 270. So whenever it says find the exact value, you have two different circumstances to look at. Either it's going to be a special triangle or a quadrantal angle. Okay, so when it's exact value, and you'll have to do that on a non-calculated part of a test, exact values are always going to be about a special triangle, either the 45, 45, 90 or the 30, 60, 90 triangle, or a quadrantal angle, because the other values we will get from a table. I don't know anybody that has the table of trigonometric values memorized. But your calculator is such a handy tool. We could certainly, in the old days when I was in high school and Moby Dick was a minnow, then we used to use trigonometric tables. Now we use calculators. Okay, so find the exact value of the trigonometric function. Now, exact values, so what do I know? It's going to be either a quadrantal angle, which we'll find out when I do the terminal side, right? And I sort of know it's not, or one of the special triangles. So doing this, I have cosine of 135, and so my angle is right up in here, my terminal side, right up in there. That comes around here, and that's 135 degrees. What does that make my reference angle? Isabella, what does that make my reference angle? Which is this angle right here. 45. So drawing from any point on the terminal side to the x-axis, that's my right angle. And then I have this special triangle with this side being -1, this side being +1, and the hypotenuse or the radius is always positive, and that's the square root of 2. So coming along here, because I'm going in the negative direction, that's a -1. But coming up here, that's +1. Question at all about that? Yes, Sierra. Okay, so Sierra again asked, why is this one negative? Because from the origin, I'm going in the negative direction. Okay, so what is my, I'll just do it down here, my sine of 135, my cosine of 135, or my tangent of 135? What are they? So sine is opposite over hypotenuse, so it's 1 over the square root of 2, which is the square root of 2 over 2. The cosine of 135, in this case, is going to be -1 over the square root of 2, which is negative the square root of 2 over 2. And the tangent is -1, opposite over adjacent. And again, we see that only the sine was positive here in the second quadrant. Now we could, of course, do our reciprocals. So the reciprocal of the sine is the cosecant of 135 degrees is 2 over the square root of 2, which is 2 square root of 2 over 2. The secant of 135 is just going to be the same thing except negative. 2. And the cotangent, the reciprocal of -1 is -1. So I didn't although, hey, I just did a lot more work than I needed to, didn't I? Is that what you're going to tell me, Charlie? Yeah. So, nothing like being an enthusiastic person, okay? All we needed to do is find this one, because that was the only thing that the question asked. So I just did a lot more work than I needed to. Right? Cotangent of -30 degrees. So, first thing that I'm going to do is draw my terminal side. So, now that's -30, but what's my reference angle here? What's this angle? What's this reference angle? 30 degrees. Okay, but it's a quadrant 4 angle. And so that makes, and this is not really to scale. So this is 1, 2. Do you agree? That's my 30, 60, 90, but opposite the 30 degrees is the shortest side. So what is the cotangent equal to? Not opposite over adjacent, but adjacent over opposite. And what would that equal? Oh, and should any of these numbers here be negative? What do you think, Sierra? Which one? Just so are we going in the positive direction? So what do you think? -1. So Sierra said just -1 because -1 is what's going down, right? Rad 3 is still going in the positive direction. So what is adjacent? Square root of 3. Opposite, -1. So that's negative the square root of 3. Question? Yeah, take. Mm-hmm. No, it never is. And if actually you use the Pythagorean theorem, it would be square root of 3 squared, which is 3, plus -1 squared, which is still just 1. 3 plus 1 is 4. And what's the square root of 4? 2, right? So, no, the hypotenuse or the radius is never negative. Okay, find the 5 other trig functions. I'm actually going to come back to this screen. I'm going to do this one. It's actually a little simpler in my mind. Okay, so there are two conditions given here. The secant is 13 over 5, and the sine is less than 0, right? So two conditions. And the first thing I want to look at in both conditions is it positive or negative? Because positive or negative helps me determine what quadrant we're in. Okay? So secant is 13 over 5. Is that positive or negative? 13 over 5. Is there a negative sign there? It's positive. So where is the secant positive? The same places that the cosine is positive. And where is the cosine positive? Quadrant 4, and don't forget quadrant 1. Everything is positive in quadrant 1, and the cosine and the secant are also positive in quadrant 4. So I put a check for that. Okay? Now I'm going to look at the second condition, and I'll put red checks for the second condition. Okay, where is the sign less than 0? Another way of saying that is where is the sign negative? Think all students take calculus, right? All students take calculus, so where? 3 and 4. What is the only quadrant that meets both conditions? Quadrant 4, right? Quadrant 4 is the only quadrant that meets both conditions. So I'm going to only work in quadrant 4. So quadrant 4, it says the secant, which is r over x. Yeah, so it's r over x, right? So I'm going to just draw a terminal side someplace in quadrant 4. It's not to scale. Okay, and then from someplace on the terminal side up to the x-axis, terminal side to the x-axis, I complete my triangle. Okay, so and this is my reference angle right here. Okay, so and the secant, which is r, everything is in this ratio. Okay, so I can use the Pythagorean theorem, or perhaps I know the Pythagorean triplet that will find y. Okay, and that's going to be 12. But it's a -12 because I'm going down. And how did I find it? I'm not going to take the time to do it right now, but by the Pythagorean theorem. Okay? Or you might just know that triplet. Huh? I just said theta r. Okay? So, so now find the 5 other trig functions. I have a triangle. Can I find those 5 other trig functions? Sure. So it's, well, I'll just list them all. I'll list all 6. The sine of theta, the cosine of theta, the tangent of theta. If you have a triangle, again, you could use SOHCAHTOA or the x, y, and r ratios. So the sine for that angle is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. Yes, Seer? I don't really know the full angle in standard position, but I do, I don't know that angle. Okay, so, and then the cosecant of theta is its reciprocal of the sine. The secant is the reciprocal of the cosine. And the tangent is the reciprocal of the cotangent is the reciprocal of the tangent. So, yes, Ariel. Where is tangent positive? It's always positive in which quadrant? All students take calculus in the third quadrant.
So whatever quadrant you're in, that is what, like, for example, since we're in quadrant C, that's going to be positive.
Okay, so if you heard what Ariel said, it's the quadrant that determines where the trig functions are positive or negative. So since this is in the fourth quadrant, all students take calculus. What is the only one that was positive? Cosine. Cosine and its reciprocal secant. Chloe, do you have a question? Yes, we don't change the sign when we take the reciprocal. If it's in the right quadrant. So the quadrant determines whether it's positive or negative. Notice we didn't really use that until we checked our answer. Some people actually do use it. They actually just take the value of the trig values of the reference angle and then attach plus or minus based on what quadrant you're in. And that would be another way of doing this. Okay. Can I go on? Okay. We're actually almost done here. Okay. So name all angles. Wait. I said I would go back to a screen. I said I'd go back to here. Right? This is the same type of problem. Okay, I'm given 2 conditions. One is that the sine of theta is negative 2/5, and the other is that negative 90 degrees is less than 0 is less than 180. So looking at the first condition. Okay, where is the sign negative? Remember, all students take calculus, right? So it's negative in the third and the fourth quadrant. Okay, now this one, the second condition is not one where I have to use all students take calculus. It's actually telling me where the possible answers could be. It's saying I only want answers starting at negative 90. I want answers going from negative 90 to 180. In other words, here, here, or here. So that's what that second condition is telling me. So what's the only quadrant that has 2 checks that meets both conditions? Fourth quadrant. That means I'm going to be working in the fourth quadrant. So drawing okay, so here that's a fourth quadrant. Here's my terminal side right here. Here's my reference angle right here. And so opposite is -2 over hypotenuse. Okay, so let's find what x is. So x squared plus -2 squared is 5 squared. I'm just using the Pythagorean theorem. X squared is 21. X is the square root of 21. So now, easy peasy, right? Can't I find, using SOHCAHTOA, my other trig, all my trig functions? Yes? Square root of 21 is positive because I'm going in the positive direction. So let's just list them. Sine of theta, cosine of theta, tangent of theta. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, down here, tangent is opposite over adjacent, but I need to rationalize that. -2 rad 21 over, that's a 21. It's -2 over square root of 21, which is -2 rad 21 over 21. I'll give you a minute to write that stuff if you need it. Did you write it down already? So I don't think any of this is really hard. I just think it's long. I think 12.3 has a lot of material in it. Would you agree? Yes, Sarah? So she's wondering what in the world, -90 less than theta less than 180, what that is. So what does that -90 is less than theta is less than 180 tell us? It tells us that we can start at -90 degrees. It could be in this quadrant, or it could be in this quadrant, or it could go up to 180 degrees. So that's what that second one is telling us. Charlie? The black check marks came from the sign being negative. So where is sign negative? Okay, in the third quadrant and the fourth quadrant. Okay. All right, so we are almost done. But not quite. Huh? Still 5 more screens. There's a lot in this lesson. Okay, so name all angles in between 0 and 360, inclusive in this case. Most of the time in your book it says 0 is less than or equal to theta is less than 360. So because 0 and 360 is the same place. Okay, such that the cosine is 0. So here's just a little hint. Okay, so if cosine sine, or secant, or cosecant, if any of these equal 0 or plus or minus 1 or undefined, then you are dealing with a quadrantal angle. In other words, the terminal side is going to be on the x, y, or axes. So notice the cosine of theta is 0, right? So that means I'm dealing with a quadrantal angle. Okay. What did I say if we have a quadrantal angle? What should we always think? Circles. Thank you, Ariel. So circles. So that's not what I wanted to do. Move the, hold on. You wanted me to move the screen down a little? Okay. So remember with a quadrantal angle, you have to think of these points where it intercepts the axes. So this point here is 1, 0. Charlie, I'll try to get this right this time. It's 0, 1, right? Here it's negative 1, 0, and here it's 0, negative 1. Could you, what does this say? Okay, so cosine of theta is 0. So what's the cosine equal to? Cosine of theta is equal to x over r. But if r is 1, which it is in this circle, cosine theta equals x. So in other words, I'm looking at this and I want to know, where is x equal to 0? Where is x equal to 0? Well, x is equal to 0 here and here. What rotation, how many degrees am I rotating to get to those points? So this corresponds to 90 degrees, and this one will correspond to 270 degrees. So what's theta? 90 degrees or 270 degrees? Ariel, you have a question? Yeah, so, well, it could be any value, but we're going to use the unit circle because it's always, otherwise you would just simplify it down to where r is 1. Charlie? Mm-hmm. Because those are the places, Charlie asked where I highlighted, is that the places that cosine of theta is 0? And the answer is yes, because cosine of theta is 0 when the x is 0. Yes, Katie?
R is equal to 1.
Yes. You're constructing a circle such that r is equal to 1.
Oh, oh.
Okay? Can I go to the next one? Oh, okay. So here we have sine theta equal to 1. So again, think my circle. So 1. And sine theta is y over r. So since r is 1, what do I want y to be? Ariel? Since r is 1 and I want this to be 1, y over r to be 1, what do I want y to be? Well, I want y to be 1 also. And where is y 1? Well, I only see one place, right there. And that is a rotation of 90 degrees. So theta is 90 degrees. Right? Can I go on to the next page? Cosine theta is negative 1. So again, I should have had it all on one page. So cosine is negative 1. So that, and cosine is x over r. So what do I want x to be equal to here? Hello? What would 0 over 1 be? That would be 0, right? But I want this to be equal to negative 1. In other words, if r is 1, I want x to be equal to negative 1. Okay, so where is x negative 1? I only see one place, right there. And going around in one rotation, because 0 is less than, theta is less than or equal to 360. So the only place that this is true is theta is, what degree measure is that? 180 degrees. We good? Now, before we do this, I want to say, what if the cosecant of theta was undefined? In one rotation, where would that be? Okay, well, cosecant is the reciprocal of the sine, right? So this means that it would, undefined, it would be, it's 1 over 0, right? The sine, therefore, the sine of theta is 0 over 1, which is y over r. What do I want to be 0? The y value. Right? So where is the y value 0? I have two places here where the y value is 0. So if this was 0 degrees is less than or equal to theta is less than 360 degrees, okay, then the answers would be theta is 0 and 180 degrees. If it was less than or equal to 360, I would add 360 in there too. Katie, was it helpful to print out these notes ahead of time? Can I go on? Okay, so now look, sine is a half. Is it going to be a quadrantal angle? No. But unlike, we may not be able to find only one quadrant where this is true, because sine is positive. Where is the sine positive? First and second quadrant. So I have a first quadrant triangle, but I also have a second quadrant angle. Okay, and in this case, since I don't have a second condition, I'll have two answers. Okay, so sine, here's my reference angle. So, and sine is opposite over hypotenuse. So by the Pythagorean theorem, here goes. Wow, x is the square root of 3. What kind of triangle is that? 30, 60, 90. And what's this theta? What's opposite the smallest side? The 30 degrees. So here, theta is in the first quadrant, theta is 30. Well, that means it's my reference angle. So this angle is going to be 30. What does that make this angle in standard position? 30 is What is it, Tate? 150. Because so theta is 150 degrees. And both of these are my answer. Because it's 180, all the way to here would be 180 minus this 30 gives me the 150. Okay. Yes. You guys getting tired? I am. You know? Huh? Well, we're almost done. We are almost done. Okay. It is a lot. Okay. So, well, you ready, Katie? Okay. Oops. So, go away. What is that? Okay. So the name all angles, you kind of, well, might be able to recognize this. Hey, cosine is positive here um, in the first quadrant because everything else is, but it's also positive in the fourth quadrant. So we have this triangle also. And if we find our reference angle here, we know this reference angle, and we can do it. Okay, so what do we have? Cosine is adjacent over hypotenuse, right? What is this side going to be? Square root of 2 squared plus y squared equals 2 squared, or 2 plus y squared equals 4, y squared equals 2. Y is the square root of 2. What kind of triangle is this? Both these sides are equal. What kind of triangle is it? 45, 45, 90. This angle here is 45. So the first angle in the first quadrant is 45 degrees. What if that means this is the reference angle, but I want not the reference angle in this, I want the angle in standard position. What angle is that? 360 minus 45, right? Which is 315 degrees. And the answer is this. Yes. Mm-hmm. Because I had to know that triangle. That triangle is an isosceles, right? Right triangle. So an isosceles right triangle, each angle was 45 degrees. And 45, 45, 90. Oops, I'm wrapping myself in this wire. Go on. It's got to be over soon. All right. This one's not hard. But you have to think about it. You've never seen it before. Sine theta is the same as sine of 40 degrees. Any ideas here? I've been dealing a lot with where things are positive and negative. Sine of 40 degrees, is that positive or negative? Positive. It's first quadrant, right? Everything's positive in the first quadrant. So where else will sine be positive? Quadrant 2. So sine's positive. So I just want to know if this is my reference angle in quadrant 2, what is this angle? This 140. So when the sine of 140 degrees is the same as the sine of 40 degrees. I sure hope this recording worked because I don't want to have to redo this whole thing. This is a lot. Yes. Can you just, we might be done. Let me see, Katie, okay? We are done. Yay. So you can all take a break until 3 o'clock. Okay? Because we've just done a lot. Okay, how do I stop this, you guys? What do I do to stop? Push this one?